Class, we're starting chapter 7. This is a lot about properties of exponents. And so exponents, we know that there is a base and an exponent of base raised to the e power. So 2 raised to the third power is translated as 2 times 2 times 2, right? You're multiplying that base number 2 3 times. So, as we start off the exponents chapter, there's some vocabulary words that are going to be new to us. So the first vocabulary word is something that we call a monomial. A monomial is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. It has only one term. So one, mono, means one. So a monomial, an example is 2, right? That's one term. You could have 2x. That's another term, and that we've seen those terms. This is something called a linear monomial. Now, when we have something like 3x squared, this is not linear. This is a non-linear monomial, but it is still one-term monomial. You can even have something as 4x squared y cubed z to the 5th power. This is all just one monomial. This is still a monomial, even though you have so many different variables. A non-example, let me do that in red, a non-example is if you have 4x squared plus y cubed z to the 5th. This is not a monomial. That's actually 2 monomials. Okay? A constant is a specific kind of monomial. It's just when it's a number, 2, right? That is a monomial. That's a constant right there. Alright, so if we scroll down a little bit, we're going to get into our first property. So there are 4 of them that we're looking at today when we're dealing with multiplication. The first title is called the product of a power. The product of a power. Now the key thing to kind of look for is make sure they have the same base. Alright? Take a moment to kind of read through the words, the symbols, and then look at the example. So the product of a power, what it's saying is that when you have 2 things being multiplied and the bases are the same but the exponents are different, you add the exponents. So here you have b cubed times b to the 5th, and that property is just b, just one of the bases, and then add the exponents, 3 plus 5, or b to the 8th, okay? This other example here, you have g to the 4th times g to the 6th power, and so since they have the same base, you just add the exponents, 4 plus 6, which ends up with g to the 10th. So, and this, again, this is only working for multiplication. So if we look at this first example, in example A, 6n cubed times 2n to the 7th. So you can actually multiply the numbers, the base numbers, so 6 times the 2. Okay, so 6 times 2, we know is going to be 12. Okay? And then now we have, maybe I'll do this in red, now we have n cubed times n to the 7th. So n cubed times n to the 7th, and that's where we use our property. They have the same base, and so it's going to be n, and then you just add your exponents. 3 plus 7 is 10. So my final answer is going to be 12 n to the 10th power. Why don't you try example B on your own, and then after you unpause it, I'll kind of show the work here. So if you see my work, first I was dealing with the numbers. 3 times 1, now there's always an invisible 1 in front of any variable, so 3 times 1 is 3. And then I dealt with the p's. Now p here by itself is really p to the first power times p to the third power, which is p to the fourth, and then same thing with my t variable, t to the third times t to the fourth. And so for my final answer, I have 3p to the fourth t to the seventh power. So that's our first property. What do you do when two bases are exactly the same and you're multiplying them? You add the exponents. Scroll down a little bit more to see the second one. If you read through the second one, the title of this is called the power of a power. The key thing to look for is just rewording an exponent of an exponent. So when you have something like this, a to the m power, and then you take that group and raise it to the p power. So if we look at this first example, and these are going to be pretty simple examples, we have b cubed, or b to the third power, inside my parentheses, and then that whole parentheses is being raised to the fifth power. And so the property here is, instead of adding it like we did in the first one, this one only has one base, you're actually multiplying these two. And so what you're doing is b to the 3 times fifth power, which is equal to b to the 15th power. Now, why does that make sense? If we had, let's say, for example, 2 squared raised to the third power, 2 squared is 4 cubed, and then 4 cubed is 64. So that's kind of how this property makes sense. If you look at example B, if you want, I'll give you a chance to try it yourself, but then I'll kind of explain it. So let me give you a few seconds. So I'm always going to start on the inside. It honestly doesn't matter for multiplication, but I always just like to start on the inside. So I have g to the sixth raised to the third power raised to the second power. And so honestly, I'm just multiplying all three of these things, but just step by step so that I could show you so that it makes sense. So I'm taking the first two exponents, 6 to the third power, and 6 times 3 is g raised to the 18th power, which is raised to the second power. And then for my next step, I'm going to look at these two guys. I'm going to multiply those so that I get g raised to the 18th times 2, which is g raised to the 36th power. So that's kind of it with the power to the power of a power, exponent of an exponent. So that so the first one, when you have the same base, you add the exponents. This one, you only have one base, but it's raised to the power, then you multiply the exponents. Now, tomorrow I'm going to show you two more things. There's actually one more multiplication property, and then how to actually simplify these expressions. So this is just the first page of the notes. Tomorrow I will give you the second page, and we'll go over it as a class.